ask for help, you can ANSYS Workbench help here. You just, no, yeah, okay, it's internet based. Okay, so you can just also have the just by clicking, and you can go to user guide. You can use the user guide and look for the solution what for the problem you are facing. It's just given, not to worry about that right now. After this, you all have seen that the modules have different things. Modules have these individual modules have different ticks. For example, this engineering data is green tick. This is arrow, question mark, and there are some other indicators also. Some other indicators also, and it has some meaning in it. So let's see what these mean. Okay, what these indicator mean. These indicators are mentioned here. Okay, these indicators, what these indicators in the individual modules have the meaning. So let's see what these indicators have mean. So the question, if you are looking at the, if you are getting a question mark, then that means you need to update, you need an upstream data. Matlab, you haven't provided any sort of data, okay, to proceed. Okay, the system requires upstream data to proceed. That means you have to provide valid essential data required. Okay, if you are this looking at this type of figure, that means a refresh is required. A refresh is required. By right clicking on the model, you can just click onto the refresh. If you are getting this solid question mark, then you need, it means that the user interaction, that means some input from the user is required, to proceed further. Okay, if you are getting this thunderbolt sign, that means an update is required. So update is basically when you have the solution you have done, but sometimes it didn't detect it, then this shows the thunderbolt sign. If you are getting this green tick, that means no attention is required and your system is up to date. Okay, your analysis is up to date. Okay, and if you are getting this sort of green tick with yellow upward arrow, then that means either an update or a refresh is required. And if you see a green tick with a pause mark, that means the solution has been interrupted, and you can either an update action is required or the resume action is required. Okay, and this timer sand clock symbol or indicator is means that the solution is in progress. Or the solution or the simulation is going on. So always remember these symbols are very helpful to know what's the requirement of the system is. Okay, now till now we have covered the this user interface. Now individual things we will be covering right now. One of them is the first requirement of any simulation or any design is what? The material selection. The material selection is very important. And we will see now how the material is in ANSYS is selected for a particular analysis. I'm just deleting this. it. Okay, I have removed the um, connections. So this is engineering data, and engineering data is showing that a green tick. That means my this block is up to date. Why it is so? Because we haven't provided the data yet. Because in ANSYS Workbench, by default, it considers structural steel as a material. Structural steel as a material, it's default material. You whether you select it or not, it will select it by default. And if you want to add some other materials, you just double click on this, and your material section will open up. Okay, your material section is popping up. Okay, you can see here it is showing your structural steel by default. If you do not want this structural steel, just click on here and it will suppress it. Okay, it will not consider in the your design. Now, if you want to add some other material, so here's the material library. Okay, material data source or engineering data source. Here you have different materials: general materials, additive for manufacturing materials, geomechanical materials, composite materials, general non-linear materials, general non-linear materials. Wait a minute. Wait for a minute. I will be. So okay, where were we? Yeah. So here you have different material groups. Journal material, you have the category of journal material. Then you can see if you click onto the journal material, there are some journal materials mentioned here. Contents of the journal material: gray cast iron, magnesium alloys, polyethylene, silicon anisotropic, stainless steel, structural steel, titanium alloys, and whatever you want, you can select. Let's say I want to select this titanium alloy. Now I have selected this, and if you see that along with the structural steel, I have the titanium alloy in my analysis also. In my analysis also. So this is it. You can have different, let's say, different group you want to go. You can have these combinations in different sort of category. ANSYS has defined, divided it into the different categories of the material. Different categories of the material. Let's say geomechanical materials: chalks, dolomite, high porosity, sandstone, limestone, and whenever you click on to the particular material, so you can see its property here. For example, I want to know the properties of the dolomite. Okay, dolomite की properties जानना चाहता हूँ. I want to know the properties of dolomite. So you can see these properties of the dolomite given here. ठीक है, these properties, let's say for example, its Young's modulus is given e to the 5.859, 58 gigapascal, 58 GPa. Poisson's ratio is given, and bulk modulus, shear modulus, and other parameters are also given. Other parameters are also given, whatever the requirement is. Now, suppose if you do not have the you do not have the material you required, but you know the you want to design something and you do not have the appropriate appropriate that the material you want to want here is not available in the library. So you can also create a new library or new material. Just click on to here and you can add a new material library. Let's say I am using new material library, new mat lib. Okay, new mat lib. I have the center. It will ask where want you want to save the data. So you just name it new material. I'm just taking these names arbitrarily. Okay, uh, just save it. Now you have created the new material library, and now you have to create some materials also. Some materials also. Let's say you have to uh, material one. I am naming this my fictitious material one. Just click on. Now it is showing a question mark. Why? Because I haven't provided any properties to this material. Any properties to this material. So let us say I want to specify the density of my material. So these properties are mentioned here. According to your requirement, you can easily uh, pick up the properties and add it here. Okay, let's say I want density in my material. I want have to provide density of the material. So density is here. Then elastic property, I want my material to be isotropic. So I just click on to here. And other properties you can also, depending upon your requirement, you can add these properties, and now you have to provide the values. So let's say my materials density is how much? Let's say 1800 kilograms per kg. Okay, 1800 kilograms per kg. Now what is Young's modulus? It is in Pascal. Okay, I am converting it into megapascal. Okay, so let's say 15,000 megapascal. 15,000 megapascal. That means 15 GPa. Okay, Young's modulus. How much Young's modulus I want? Let's say it is 0.2. Now, now you can see your material has been defined, and what it's uh, there is no question mark. That means that you have specified the properties required. Okay, you can add some other properties also, what you required depending upon your need. So this is how you select the material and define new material into the libraries. Okay, is it clear up till here? Huh? I hope yeah. So I have defined the material now. What I need to do is material properties are defined. अब इसके बाद क्या करेंगे भाई? हमने material decide कर लिया. I have decided the material. Decided the material. Now I have to do what? I have to have the geometry, or the uh, geometry, or okay. So in ANSYS, what it provides is it gives you three options to have the geometry. Okay, it has, you can click on, right click onto the geometry part, and you will see the options. So it has new space claim geometry, design modular geometry, and import geometry. So whatever these three options, the first two, new space claim geometry and design modular geometry, it is basically providing you the platform. It is a platform where you can create the geometry, and import geometry provides you the option that you can import the geometry. You can import the geometry that you have earlier made on the softwares, other softwares like your AutoCAD and CATIA or ProE or SolidWorks. Okay, and there is some requirement for that. Okay, there is some requirement for that. That is the file format to import the geometry here is in general IGS or IGES. Okay, it, it accepts if you have created your geometry from on some other platforms you have to convert into specific format, and it accepts IGS and IGES format. Okay, now I will show the user interface of the design modeler. Okay, uh, so where you can create the geometry by yourself in the ANSYS. Okay, so it is the user interface of the ANSYS design modeler. ANSYS design modeler. It is basically general the um, it looks like some other software. It has the features some other softwares, but it is, if you are having simple geometries, it is advisable that you can go with this design modeler. You can go with the design modeler, but if if you have if you have if you have the complex shapes or complex geometries, then it is not advisable to use design modeler. It is not advisable to use design modeler. Okay, you can create, but it will take a lot of time to create in here. It is advisable that you use some other dedicated software for that. Okay, so I will just show the simple uh, I will create a simple geometry, let's say a beam. So you can just look onto the plane and go for the sketching part. Let's say first I will turn on the grid. Okay, turn on the grid. The grid is on. Now I would like to draw. You can just for creating a beam, so let's say a rectangular beam. A rectangular beam can be created. No. I have created a beam. You can dimension it. You have the specify the specific dimension. Just click on to here or general dimensioning, and whatever length you want, you can change it. I haven't changed the unit here. It is in meters. So first of all, I will change the unit system into millimeters. So it is showing 2000 mm. Okay. Uh, let convert it to 20 mm or 40 mm. 40 mm. 40 mm. So it is okay. Let's create from the scratch again. Okay, now grid is on, spacing on. Grid is from, it is major grid spacing is showing 5000. Let's convert it to 10 mm. Okay, minor grid steps is again 10. Okay, now we can look onto this. Yeah, that's good now. So we have the setting. Now we can draw the uh, our beam portion. Beam. Yeah. Okay. So your beam has been created. If you want to give the dimension, I have already taken it in such a way that by looking onto these blocks, major steps, I have created this cross section of the beam of 40 cross 40 mm. Okay, if you want to give the dimensions, you can give the dimensions as per your requirement. You can have the modified tools, fillet, chamfer, corner, trimming, and all the other things are given here. Okay, so I am not going to do this. When we will be doing our hands-on session, we will be making some diagrams related to this. Okay, now after you have created this, you just click on to the generate. Now your sketch has been generated. Go on to the modeling. You can see your sketch has been created. Now what we do is we can extrude this geometry. What I have just selected the sketch one and apply what I want to extrude. And what is what the next thing I have to do is, what the next thing I have to do is how much I want to extrude it. How much I want to extrude it. So let's say I want to extrude it to the 1000 mm. So you can see it has some. It is showing some projections. The geometry or the beam hasn't been generated yet. You just go on to click and generate. So you can see the beam has been generated or beam has been created. Okay, beam has been created.
Sir, you
ठीक.
repeat the
Yeah.
commands, sir.
Okay. You want me to repeat the command?
To
Yeah.
start, यस सर, ये पूरा जो आप स्टार्ट किया हो पूरा.
From where? From sketching. You want me to go from the sketching?
No sir,
Okay.
start from the sketches and before.
Okay. Okay, it's basically just to show you can do the thing in this also. Most of the commands and the user interface is similar to the other dedicated softwares. So first of all, in what plane I just want to create a beam, rectangular beam. Okay, so I have selected a plane. So first of all, I will create the cross section, rectangular cross section. Let us say I wanted to create 40 cross 40 beam of length what 1000 mm. So first of all, I will create the cross section and I will extrude that cross section
So
in
this
the
toolbar is shown, is where
yeah.
toolbar and this screen, sir.
Yes, what are you asking?
Sir, this
Yeah.
is toolbar is changes before 5 minutes ago.
Yes, yes. If you select different commands, okay. If you
Yes, sir.
select different commands, it will change obviously because let's say if you select extrude, so it will ask something that is
Okay,
related
okay,
to
okay, okay.
extrusion of
Yes, sir.
the
Yes.
object.
This
Okay,
option is yeah, yes, sir. Okay, okay.
okay. These options that
Yeah,
are changing is related to particular command. Okay,
I am seeing that, sir. Yes, sir. Thank you.
okay. So now, as usual, I have selected the plane for the cross section. Plane for the cross section, I have selected the XY plane. Now I go to the sketching and just create the um, the cross section of the beam. This time I am using rectangle. Okay, rectangle. So it is, yeah. Okay, so I have just created. I'm not going to specify the dimensions of this. If you want, you can just click on to this and just select and you can specify the dimension. It has already taken 40 mm. I have drawn this in such a way that it has already taken 40. And vertical line, you can also see that V3, the vertical line, it is how much? 40 mm. It is already taken. Okay, now I just go on to the click generate and the my sketch has been generated. Okay, Now my sketch has been generated and I can extrude this sketch and go on to the modeling, select extrude. Yeah, now it is asking on what geometry you want to extrusion. आप किस geometry पे, यहाँ पे तो एक single geometry है तो by default यही होना होगा. If you are having multiple sketches then you can select specific sketch. Then it is asking what how much extrusion you want. I have specified how much 1000 mm. It has some other options also. Add material, okay, add frozen and some other things. Even if you are having different some complex shape, it will show some more options also. So that is not needed here to tell, because if I go on to that, the whole session will go into this explaining these things. So let's go and just generate it. So I have generated the sketch. Okay, this is how it is. Now it is okay. I hope यहाँ तक हम लोग अब आगे बढ़ सकते हैं. So now you can see your geometry is showing a green tick. Your geometry is showing a green tick. Okay, your geometry is showing a green tick. That means your geometry part is okay. Now go on to the model, and when you open the model, now everything starts here. All your things starts here. So let it open. So when you open this, all everything related to your particular analysis will be here. Here my main focus is to show you about the meshing part. About the meshing part. Okay. About the meshing part, I have to discuss it in detail actually. So before proceeding in this, I just want to go to some theory portion of the meshing. Okay, theory portion of the meshing. It is very important. The one thing I would like to tell you that the most important thing in any simulation software, in any FEA simulation, is whether you are doing it on GUI, graphics user interface, or you are writing a code. ANSYS is GUI, graphics user interface, because you can see or you can visualize the everything and you just clicking on to the commands. There are some other softwares also, and even in ANSYS there is an option to write codes. You can write computer codes for FEA analysis. Okay, but that is way too advanced for your at your level. So we are not going to discuss that. But before that, whatever you are doing, whether you are writing the code or you are using GUI, you the most important thing in any FEA analysis is this meshing part or discretization. Okay, meshing part or discretization. Is there anyone who can tell me? It has also been discussed in the last session also. What do you mean by meshing? Meshing से आप लोग क्या समझते हैं? What do you mean by meshing? Anyone from the audience?
Sir,
I think
material
it also means
material
discretization.
to break.
One by one, please. Yeah. Yeah, there were two people. Anyone from you all? Debdi,
Discretization.
yeah. What do you understand by discretization?
Dividing the elements into small parts in order to analyze to get a nearly approximate value to the original value.
Okay. Okay, it is correct. Absolutely correct. Anyone else wanting to add some more information or more light? Yeah, basically it's Absolutely correct. Yes, absolutely it is correct. In discretization or meshing, what we do is we we divide our system into small parts. But here the talk is why we do this. Why we do this? Hmm? So the reason for that is because if you take any system or any material, okay, to analyze it perfectly, because it is made up of what? Atoms and molecules. And let us suppose if you want to analyze a drop of water, a drop of water, can anyone tell me how many molecules of H2O is in there? Huh? How many molecules of H2O is in there? Can anyone tell? Obviously it is way too much above our counting. So again here in any system we can consider it that the number of elements or the number of points, the atoms or molecules, because they contribute to the system. So if you want the perfect analysis, you have to analyze each and every atom and molecule, each and every atom and molecule. So if you are going to do that, to, then you to analyze a simple single drop of water, single drop of droplet of water, you will be spending years, सालों साल लग जाएंगे. ठीक है, because there are many infinite number of we can consider that infinite because that is way too large. So what we do is we discretize the system, or we convert this continuous system into finite that consists of infinite elements. We convert it into what? Finite number of elements, finite number of elements. Okay, so you can see this is a continuous system, this is a continuous system, and I have converted into the finite system. Okay, so now what I have done is I have divided into small parts. Okay, so whatever, this is my one element, this is one element, 1 2 3 4 5, 1 2 3 4. So there are 20 elements here, 20 elements here, and you can see these elements are joined to each other, or these elements are connected to each other at some points, and these points are shown in the blue color, and these points are known as what? These points are known as nodes, and the element, this portion is known as your element. We are having 20 elements, and how many nodes? 1 2 3 4 5, 1 2 3 4 5 6, 30 nodes, 30 nodes. Okay,
29, sir.
29. Okay. Okay, 29 30. ठीक है. Okay, it is 30, 39 or 30 nodes and 20 elements. Okay, so now I have to solve only for these 30 nodes and 20 elements only. I'm not going to solve this system for infinite elements. Okay, infinite elements के लिए अब मैं solve नहीं करूँगा. ठीक है. एंड अब इन्हीं एलिमेंट्स, क्योंकि जब ये छोटे छोटे एलिमेंट्स हो जाएंगे ना, इनको जब हम छोटे में डिवाइड कर देंगे, देन व्हेन वी convert them into small parts or small elements, then we will be having we can analyze them very easily. Okay, so everything, every equation what we were going to apply on this whole system, now we will be applying those equation individually onto the every element. For example, I have to analyze the stress, stress analyze करना है. ठीक है, स्ट्रेस एनालाइज करना है, एंड स्ट्रेस एनालाइज करना है. तो स्ट्रेस की इक्वेशन क्या होती है भाई? डिफरेंशियल इक्वेशन फॉर
P upon
स्ट्रेस
A.
इज, लेट्स से P upon A. No, differential equation. I am asking differential equation. Okay, del x, del sigma x. Sigma is my stress, and x is the this x coordinate is equal to plus f of x. It is a force depending upon the function. and equal to 0. It is the simplest stress equation for one dimension, single dimension के लिए हमारे पास ये stress equation है. Now earlier I was going to apply this equation onto the whole system. Now I am going to apply this system or this equation onto this element, this element, this element, this element, this element, and all the other 20 elements. ठीक है, इन सभी 20 elements पे मैं apply करूँगा. I will be applying this onto the every element, and then every element will give me some results. Every element will give me some results. I will be solving this equation for each and every element. Okay, and then every element will be giving me some results. ठीक है, कुछ results आएंगे. ठीक है, and I will be what, summing up those results. I will be summing up those results to give an or to make an overall result for this system. Overall result for this system. Overall result for this system. ठीक है, ठीक है. So what I have done there in this, I have discretized or broken the system into small parts, and then I have applied the differential equation for the system onto the every element, and then solved that differential equation for every element, and we get some results, and we summed up all those results from the individual, and then we have got what, overall result for the system. Overall result for the system. Okay, so here your discretization plays a very important role. Here your discretization plays a very important role. What is that? It is very important how you discretize. How you discretize, या आप meshing कैसे करते हैं, how you do the meshing. Okay, so the most crucial part of the HVA simulation is your discretization. So mainly, I'm not going to much detail. Okay, we ये elements पे तो बाद में आएंगे. Okay, so ठीक है. अच्छा, अब एक चीज इसमें ये देख लेते हैं कि आपका जो ये डिस्क्रिटाइजेशन है, so you can have different type of geometry, different type of element. So based on different type of geometry, you are going to have some different elements. For example, here you are looking at a 2D element, because your system was in 2 dimension. Let us suppose you can also have different type of elements. You can also have different type of elements depending upon the dimensions. One of them is one-dimensional element. Second one is your 2-dimensional elements, and third one is your 3-dimensional element. Okay, so different elements are used for different applications. For example, where you will be using 1D elements. 1D elements आप कहाँ use कर रहे होंगे? You will be using 1D elements where your cross section is very small and your length is very large. Okay, your length is very large. Okay, then there you can use 1D element. Okay, and 2D elements आप कहाँ use करेंगे? It is 1D का example आप देख सकते हैं. Beam, in case of beams and truss problems, you can use 1D elements. But let us suppose you are working with sheet metals, tin sheets, or the roof sheets, or the body part, outer covering or outer body of the automobiles, where you have the large dimensions in plane. In plane you have the large dimensions, but in thickness it is very thin, so you can ignore the thickness, and in those cases you use what? 2-dimensional element. Okay, 2-dimensional element. Okay. And now the third 3-dimensional element, that these type of elements have both length, width, and your thickness also. ठीक है. One more thing is your element, uh, any of these, either 1D, 2D, or 3D, it can be linear also, it can be quadratic, or it can be cubic, and even higher order elements can also be there. So, what do I mean by linear element? If you are having 1D element, if you are having 1D element and you are having only two nodes, then it is linear. Because line की equation लिखने के लिए, for writing the equation of line, you need what? 2 points. ठीक है, you need 2 points. If there are three nodes, the single on a single element, on a single linear element, if you are having three nodes, okay, then it is quadratic. ठीक है. And then if you are having four elements on a single node, 1D element पे आपके चार nodes हुए, तो that will be cubic. इसी तरीके से in a similar way, if you are having there are two types of element: triangular, आपका planar element, your planar or 2D elements can be in triangle form or rectangular form, and in even some cases you can have polygonal element also. So they can also be what? Linear, quadratic, and cubic, and even of higher order. So here it is showing linear only, because on every edge you are having, or on every vertex you are having only one node. And if you are having one node on each edge also, so this is going to be quadratic. You increase some other number of nodes on the edges, you can go for the cubic. Okay, you can go for the cubic. But the problem with this is what? As your number of nodes is going to increase, your computation time will increase. Okay, so it is very it comes from the experience, or the accuracy you want in your results. On that basis you decide what type of element you use. Okay, first you decide either you are going to use 1D, 2D, or 3D, and if when you selected 1D, 2D, any one of them, then you have to decide what type of element you are going to use: linear, quadratic, cubic, or some other type. Okay, or even of higher order. But remember always, as you go higher, your computation time will increase. Okay, so because number of equations to be solved will be increasing. Okay, so it is the same thing that I have explained earlier. It is showing this different type of element. 1D element, it is linear. 2D element, 1D element में quadratic, 1D element में cubic. 2D element में ट्राइंगुलर टाइप एलिमेंट लिया हमने, एंड इट इज लीनियर, क्वाड्रेटिक, यहाँ पर एक और होना चाहिए, ठीक है, एंड देन योर क्यूबिक एलिमेंट. Similarly, you have 3D element. It is linear, quadratic, and cubic. Okay. In elements, you have some other classification. Okay. It is triangular basis, as I have already told. In 2D, you can also have what? Where is the cursor? Okay, here. Yeah. Sorry. You can also have what? Rectangular element. And in here, you are having, in 3D, you are having what type of element? It is tetrahedron. Okay. You can also have this type of element. Okay, cubic element, और इसको हम hex element भी कहते हैं. We also call this hex element. Why hex element? Because this cube is going to have 6 faces. ठीक है, 6 faces. So even you can see that we are having these two types of elements, extra elements in this. You can either use triangular or quad element, or you can use tetrahedron, or you can use hex element. These type of elements actually define, creates a categorization. If your system is using triangular, or you are using triangular or um, tetrahedral elements, then you are going to have what? A non-structured, yeah, non-structured non-structured meshing. And if you are using this type of elements, okay, in general it is not the criteria, but if you are in general, if you are using quad and hex element, then you are going to have structured mesh, okay, structured mesh. Okay, so you can see this geometry that is shown on the left side. It has all the quad and hex elements, and over here you can see, that what it is using all the triangular and tetrahedral elements, and it is your unstructured mesh. So everything has its other importance in meshing. Structured elements are always preferable, but to create a structured mesh, because these are, you can see, this is very neat and clean. You can see, okay, this one is very neat and clean, but this is very haphazardous. Sorry, haphazardous. Okay, so uh, it is always preferred, but it is always difficult to create. Okay, are you getting this? So in complex geometry, for simple geometries it is very easy, you can simply create. But for complex geometry or complex shapes, it is very tough and time taking to create the structured mesh, so we always rely on the unstructured mesh. Okay, unstructured mesh. So in ANSYS, we generally use the option that ANSYS provides is these two types of elements. Okay, these two, triangular and quadrilateral, and tetrahedral and hex element. Some other software provides also polygonal and polyhedral elements also being provided in the some other software like hypermesh and like this. So in check, okay, okay, so check, okay, so this is all about the element type and that ANSYS offers. Now I will take one example and show you how to do meshing. I have already created the geometry. Uh, Let it be open. And till now, if you have any query, you can ask related to this. Hmm? No? No one is having any query? Okay, let it open. Yeah, this is it. So, so as you can see, I have this geometry of a lifting log. It is used to lift up the objects. Okay, so it's a basically hook type of design. So to show you how this meshing works. So basically, first of all, in this geometry, you can see there are two bodies, two different bodies we are having here. And for meshing, first I will show you the default meshing. Default meshing, I will show you the default meshing. Okay, default meshing I am showing you. Just click on to this and generate mesh. So I'm not haven't adjusted anything here, and it is showing the default meshing. It is very coarse mesh. Okay, the system has already divided it into small parts, and this is your mesh. Now in ANSYS meshing, you have some options. Okay, so there are two. Basically, this meshing part has been divided into two parts. Okay, the first one is the global meshing. Global meshing. Okay, so all the things, when you click onto the mesh here, you will be looking at some these things: display, default, sizing, quality, inflation, advanced, and statistics. So first see statistics में आपको पता लग जाएगा. You will be looking at in statistics, you will be having how many nodes are there and how many elements are there. Okay, number of elements and number of nodes has been given here. So now what ये तो हमने बाय डिफॉल्ट कर लिया. ठीक है, नाउ वी विल बी लुकिंग एट ग्लोबल मशीन में. वी इन ग्लोबल मशीन वी आर गोइंग टू सी what we can do by doing such things. Okay, so let's say here in display you are having some options. Okay, first one is geometry. So if you select this, by default it is selected. It shows your the geometry after meshing. Then element quality. If you select element quality, then it will show how good your element is and how bad your element is. Okay, your element quality should always be equal to perfect element. Is that has what? Perfect element is called which has element quality 1, which has element quality equal to 1. Okay, and very imperfect element is which is having 0 element quality. So you can see this is not a perfect mesh. This is not a perfect mesh. The bottom part is close to perfect, but the upper part is having not that good quality. Even you can see this red portion, this element is very bad. Okay, it has element quality close to 0.3, close to 0.3. So, and some other options are also there. Aspect ratio, these are quality check parameters, Jacobian, warping factor, and these things are your quality. Mesh quality आपकी कैसी है? How your mesh quality is, to check we can use these parameters. Okay, these parameters can be used to check how good your mesh is. Okay, so right now I'm just using the geometry. And then your second thing, by default it is selected physics preference is coming. So what kind of physics you are using in your simulation? For example, I am a mechanical engineering student. I'm going to use the mechanical system. Let us say if there is a person who is electronics engineer or electrical engineer, and he wants to work in the field of magnetostatics. So it provides you some options. Let's say you have mechanical, you have non-linear mechanical, you have electromagnetics. Okay, electromagnetics. You also have CFD. You also have explicit dynamics. Okay, car crash test वगैरह जो करते हैं, the people who use car crash, who do car crashes test or simulation, they use explicit type of meshing. Okay, so depending upon the physics you want, or you are working with, you have to select a specific preference, physics preference you have to give physics preference, and by default our system has selected mechanical. Now over there, just beneath this, there is element order. Element order. By default, it is selected program control. Okay. So what I was talking about, the element order can be linear, quadratic, and linear, quadratic, and cubic. यहाँ पर cubic नहीं है. There it just provides linear and quadratic option only. So what that means is, I just want to show you that you can just see elemental nodes. Okay, so by default it is selecting, you can see if I check these elements, so I have this whole element, ये मेरा element है, this is my element, and on the edges you can see it is having three nodes. So what type of element is this? It is quadratic in nature. It is quadratic in nature. Let's say I select this linear type. I have by default selected it linear type, and now I do the meshing. Again. Then I can see what I can see. Yeah. Now I can see what? There is no element in between. You can see there is no element in between. See, but earlier when program control, by default it has selected quadratic type of elements, and that's why there were three elements on the single edge. So this is how you can check the element order, or you can change also the element order. So I am keeping it default. Okay. Now what the second thing is, other thing is below this, by default it has taken some size of the meshing. You can also define your own size. Currently it has taken 5.6 mm size. Let's say I just provided the size of 0.001. I am providing it the size of 1 mm. So I have given the element size, and now I can recreate my mesh again. So first I delete the earlier one and then generate mesh. So obviously this time it will take some time, but not that. Yeah. Now you can see this is very fine one. Okay, this is very fine. Earlier you were having what? Very coarse mesh. Now you have a very fine mesh. Even you can now go much smaller. But what's the need? Just to it depends totally on your problem. ये totally आपकी problem पे depend करता है कि आप कैसा mesh चाह रहे हैं. ठीक है ना? कितनी accuracy आपको required है. Okay. Now you can also see the element quality. Now it has quite improved. Relatively, you can see that the red marks has gone. The red marks has gone now. Okay, the red marks has gone now. Now coming to the sizing. Here it is selected. There are three things that I have to cover. Here, use adaptive, capture curvature, and there is one more option, capture proximity. So what are these things? Let us suppose if you have a simple geometry, adaptive features, this use adaptive sizing means basically it automatically selects or chooses element according to the shape, according to the geometry, and there is no need to specify. You do not have to specify anything. But in capture radius, in capture curvature, if you are having complex geometry having multiple curvatures, so it will take care into consideration for the curvature or bends also. Okay, bends also. Okay, you can see here we are having a curvature. So my system capture curvature is on, so my system or the system will all automatically take care of this thing, that what type of how it should do the meshing, so that curvature do not distort, or the radius, ये जो curve आ रहा है, the curvature here it is coming should not get distorted, or it should replicate it in such a way that the accurate curvature or accurate curve is traced during meshing, traced during meshing. Okay, traced during meshing. Okay, now here is the option of proximity. I have turned it off. By default it is turned off. So what does that means? There are multiple surfaces, there are multiple surfaces in here, and when there are multiple surfaces, so let us say uh, it is not that good geometry that we can have the proximity issue. Let us say कि यहाँ पर आपका here you have one surface here, one surface here and one here, they are in close proximity with each other. So when you are having surfaces or these curves very close to each other, not in connection with each other, but we are very close to each other, okay, then we have to take into the consideration of the proximity, closeness of uh, those surfaces or those objects while doing the meshing करते वक्त हमको उनकी क्लोजनेस का ध्यान रखना होता है, बिकॉज दैट कैन क्रिएट एन इशू. ठीक है, क्वालिटी ऑफ मेश कैन बी रिड्यूस्ड. ठीक है, quality of mesh can be reduced. So these are the things that you have in the global meshing. Global meshing, depending upon your requirements, you can turn off the different features and turn on the different features. Okay, now you can see as we have changed this size, it has the number of elements has shot up. ठीक है, देख सकते हैं पहले हमारे पास नंबर ऑफ एलिमेंट्स कितने थे भाई, अराउंड 150, सॉरी 1500 के आसपास थे. नाउ वी आर हैविंग 1.5 लाख एलिमेंट, 1.5 लाख एलिमेंट्स, 100 टाइम्स इंक्रीज हो गए एलिमेंट्स हमारे पास, 100 टाइम्स इंक्रीज हो गए. सो लेट्स go to the default. Okay. This is the meshing part. Now I have this we can go to the local meshing, and we have different methods here. First we select methods. So what I have told you, on what geometry you want to do the meshing. Okay, I want to do the meshing in here. Okay, in these two objects I have selected. Now what method, कौन सा method आप apply करना चाहते हैं, what method you want to use for the meshing. So the method by default it is selecting automatic. You can also change it. You want tetrahedron, you can. You want hex dominant or hex elements, you can choose hex elements. Okay, hex elements. So select hex elements. So now generate mesh. You can see, yeah, now your all the elements here are hex dominant. Can I reduce the size? Yeah, for sure. 0.01, no, 0.1. If I select this, then you can see the difference between the hex dominant and tetrahedral. Okay, hex dominant and tetrahedral elements. It is taking some time. Let's wait for some time and then we can proceed further. let's wait till it proceeds. Oh yeah, yeah. Now you can see all the elements here we have converted into hex dominant or hex elements. So 6 faces elements में हमने इसको convert कर दिया. Now you can see the element quality. Element quality आप check कर सकते हैं. Element quality. Earlier we were seeing some red marks and yellow patches in here, but after converting into hex dominant element, you can see that our mesh quality has improved a lot. Our mesh quality has improved a lot. It is close, in most of the cases it is close to 1. In most of the cases it is close to 1. Okay, so this is very important part. The meshing is very important. There are some other options also. You can have different methods. The time is limited. I cannot explain all the uh, methods to show different meshings, what they have, the effect on the meshing. So, but I hope you have got the idea. Okay, key meshing is a very important part, and you always keep in mind. You always keep in mind while doing the meshing that your mesh quality, it is going to play a very important role on the results you are going to get. Okay, you are going to get it is going to have a very big impact on your results. Okay, finer the mesh, finer